Hi, my name is Rebecca, and I am going to answer this question from Michael. This question is a heat question. What it is asking for is the final temperature when a piece of or a block of aluminum absorbs this much heat. The equation, or what I would start with first, is by listing all the information in the problem and also what we're looking for. That's going to help guide me to figuring out how to get what I'm looking for. So I made a list. First, it gave the volume in centimeters cubed. It gave the heat, which just so happens to be Q. I'll label that here in my equation too when we get to that. The initial temperature was 38.5 degrees Celsius. I'm assuming that's what's missing here is degrees Celsius. I call that TI for the initial temperature. Some teachers might call that T1. And then TF is what we're looking for. That's the final temperature. Again, some teachers might call that T2. And then they also give us this sort of hint here that the density is 2.70. That, and the units for that is grams per centimeter cubed. The equation that we use to convert from heat to temperature is this one here. This is heat, Q, mass is M, C, or sometimes written as S, is specific heat, and delta T is change in temperature. Change in temperature is going to be delta T equals T final minus T initial. At this point, if I go back and I look at what variables I have and which ones I'm missing, I can sort of see where I need to, or what else I need to do. So I do have Q. I'm looking for M. I don't have M, right? I don't have C. And I have TI, but not TF. So I have enough information here to find mass. So that's the volume and density. Density equals mass over volume. I have density and volume. If I just rearrange this equation by multiplying both sides by V, I will get the mass. And I can also see that when I plug in that my units will cancel and give me mass units of grams. So if I go ahead and plug in 2.70 grams per centimeter cubed times 96.5 centimeter cubed, I get a density of 260.55. And I'm just going to keep some extra sig figs here. Sorry, a mass of 260.55 grams. I'm going to keep extra sig figs here until the very end to my final answer, and I'll go over significant figures at the end for this problem. That gets me my mass. So now I have that piece of information. C is a constant that I can look up in a reference. So I just Googled it earlier, and I found that C for aluminum is 0.900 joules per gram degrees Celsius. This is the amount of heat that is absorbed or lost, depending upon if the temperature is rising or falling, per gram of aluminum needed or to raise or lower 1 gram by 1 degree Celsius. That's what specific heat is. And that's a value, again, it's a constant that you can look up for any given material. Each material has a different specific heat. And you have to also watch out for what phase it's in as well. You may do some problems with water. You have to be careful. The specific heat of water is different for ice versus liquid water versus steam. Anyways, at this point, we now have C as well. So we have all the information now to plug in for T final. The heat, the mass, the temperature, the final temperature is what we're looking for in the specific heat. So I have 69.5 joules equals 260.55 grams times 0.900 grams, joules per gram degree Celsius, times T final minus T initial, which is, plug in, 38.5 degrees C. Now you just have to worry about the algebra a little bit. You're going to take 69.5 and divide by the mass and divide by the specific heat as well, and then add 38.5, and you're going to get 38.8 degrees Celsius. And as far as significant figures go, I have 3 significant figures here. This really should have been 3 significant figures as well. This is a constant, so we don't have to worry about it. So when I get to my subtraction piece, I should have 3 sig figs minus 3 or plus 3 sig figs, which is, let's see, 0.296. And then I'm going to add 38.5. So at the point, that very last step of algebra, I have 3 significant figures with 3 decimal places plus 1 decimal place. So my final answer should have 1 decimal place. And that is it. Thank you.